Hello beautiful people, Wayne Hackman here, aka Whackstar, and this is part 2 of the Sunjuice challenge. In my last video I outlined my thoughts of trying to take my office completely off grid with the hope that perhaps I could expand across the entire part of my home. And so I showed you some of the items that I bought, outlined my vision, and got to work. Well, it's a few weeks later and I've got the bits and pieces wired up together in what I think is quite a good configuration. So this is a kind of dry fit, but I just wanted to run you through what I've done, and then we can switch the unit on for the first time and see what happens. I needed something to put all of this in, and because I don't own the house that I live in, we needed to create a box, which I got a local charity to make, for all of this system to go in. I put some casters on the bottom, so if I had to move pretty quickly, we could roll this system out of the house, ready to be installed in the next house. Inside the box, there is a small distribution box, which has both AC and DC breakers in there, and I can take 2 different strings of solar panels which I want to utilize later. On the outside you will see a 13 amp socket, and later I actually added an industrial socket where I could plug the house in. There's also this DC breaker switch here as well, which can isolate those 2 strings of solar panels. So this is what it looks like in its first dry fit. You can see that the battery goes inside with space to add more batteries, and I've had to put the inverter on the outside because it needs to be well ventilated. So the first part of the purchase was this Deye hybrid inverter charge controller, and this is a 5 kilowatt system which will be more than enough power for my office with a little bit of overhead. When you take the front panel off, you can see there that it has a supply. It also has a link to the power company and also a generator tie-in, a whole load of control ports which can also be used to configure this system to your needs. I've not turned it on yet, but I have wired it in, and what we've done so far is we've put the battery wires in, the solar wires, and also the power wires, and I've kind of dry fit that all together, not forgetting the little Wi-Fi module which is underneath here as well, that came with this particular kit. Now, what is this putting energy into? Let's go and have a look. So this is a Dyness energy storage system, and this is a lithium battery model. It's the DL 5.0, and this can deliver 5.12 kilowatt hours at a maximum output of 100 amps and delivers 52 or 51 volts output. And so the inverter in a minute will be connected through these supplied cables that came with this particular system, and also I need to work out the correct configuration. So I've got some control cables here which I need to do some research on before I switch this thing on, and dip switch settings which lets the inverter talk to this system and vice versa. The cool thing about this is that you can also daisy chain in parallel more systems, and that will, all being well, you know, if I find that I need more energy, I can add more of these lithium batteries on top. It's also rack mountable as well, although it's 50 kilos. It's a heavy piece of equipment. This is Chinese made, but comes highly recommended. So the inverter came with 2 control cables. We've got what looks like a standard Cat 5e patch cable. It's about 1 meter long. But then there's also this battery cable. If you look at it initially, you'll think it's another Ethernet cable, but when you look up closely, 2 of the pins are wired. And so this is the battery cable. Now, I'm not too sure if plugging this in or plugging this in, depending on what battery it is. So that means I have to look at the instruction. we have the BMS 485 port for battery communication at the various connectors. So it will be this one here, the BMS 4, so it's this socket here. So we need to now just make sure that we're going to use the correct connector, whether it's the Cat5 cable or that battery connector, and also need to have a look at the Dyness manual to see exactly which one is the correct one to put it into there. We have some dip switch settings on the battery, and it looks like this. When the battery works with all of these ones, we're looking specifically at the Deye, the sun sync, I think in some places. We need to set our dip switches to number 3 up. Let's do that now before we proceed with plugging the battery in. Here are the dip switches, so let's just flick up number 3. We're going to plug it in. I think I've configured it all correctly, but I think the only way to find out is if we plug it in. Now I like these connectors because they just literally push on nice and safely, which is quite good, and they click like this. And then we can do now the same for the negative. Let's push this in. Right, there was no spark or click or anything like that, so it suggests that all is well. Okay, so I think I've got the dip switch settings set correctly. I've got the battery plugged into what I think is the correct one. This is the big moment of truth. I've switched it on. I've not heard of anything. There's this SW button. If we press that, there we go. Something's happened. We've got a run light flashing. I heard a buzz. I'm assuming flashing is good. There is no alarm. Right, so this is the moment of truth. Has in fact the inverter powered up? Let's go around and have a look. And no. Nothing on the inverter. I know what the problem is. There's an on-off button here. Pressed it. Nothing's happened. Oh, I can hear some clicking inside it. Anything happening in there? Oh, yeah, we've got lights. Yep, all good. There it is. It's powered up. Ha! Okay. So far, so good. Now this is just running off the battery. Let's go around and have a look at the battery to see if that run light has stabilised. So we'll go around and there it has. So obviously needs to talk to the device, which suggests to me the battery is set up properly. So let me just have a little fiddle with the configurations. Of course, I would thoroughly recommend not turning your inverter on without the protective cover off, because we've got some very high voltage going through here, but I'm going to be careful. So this is a touch screen, I believe. Yep. There we go. So you can see, you can navigate the system. There we go. So I fiddled with some settings, and we can see now that that battery came charged at 52%, and it's obviously delivering a little bit of energy. I guess that's the energy it needs for this particular device to be active. So it's about 0.02 to run this system. I've also disconnected the grid at the moment, because one thing that scares me about these bigger systems is the last thing I want to do, particularly here in Kenya, is send energy to the grid, because Kenya's not set up for that, and there potentially could be that possibility of really hurting someone if I've not set up properly. So I've got a little 200 watt panel that I use for my systems that I give away, and you can see at the moment there's a reasonable amount of sunshine. This is only less than 10% of the big panels that I've got, but I wanted to just see if the system is charging. I'm not going to put any load on it yet to see if we can get some charge into this system. Of course, it will probably take a considerable amount of time for a system like this to charge the big battery, but let's plug them in and see what happens. So they're plugged in. These will eventually supply the big system, but before we do that, I just want to check that I'm not going to cross the streams, that positive is positive and negative is negative. Let's check that now. Negative touching there, and positive touching there, and what do we have? We have 18.46 volts. Not a lot, but let's see if it makes any difference to this system. So I'm going to plug this into there now, and then we'll have to switch the whole system on and see if there's any power coming into it. So we got 45 watts of power going in at the moment of that 200 watt panel. A small amount of solar energy going into it, which is great. The inverter is talking to the battery, which is fantastic. It looks like, although albeit a small amount of wattage going into this, that it is doing something. There's a very, very high pitch, quiet sound, which kicks in when I'm guessing the inverter has enough energy in it to then charge and discharge the battery. I think that this panel is not providing enough energy to actually make a difference on this battery here, but I need to go and do some investigation. There's just one more thing that I want to do in this video, is to see if we can get some power out of this system. So I'm going to get an electric lamp, we'll plug it into the 10 amp socket, we'll power it up and see what happens. Let's switch the master breaker on, and then the 10 amp. Nothing has exploded yet. Power on. There we go. So thanks so much for watching. The couple of rookie mistakes, which I'm learning as I'm doing, and I'm sure that there are lots of people here that can give me advice on how to make this better. But we're putting some very basic solar into it. We've tested the system and done some basic configurations. We've even got a little bit of 240 volt power coming out of it. Now, there's a lot more to do. I'm going to turn my attention now to the big solar array. I'm also going to just work out how to put this onto the internet and start configuring it correctly. But for a first moment of experimentation, we seem to be heading in the right direction. Thanks so much for watching. Stay tuned for the third part of the Sunjuice challenge, and well, do all of the things that YouTubers do. Rate, comment, subscribe, perhaps even give me some advice on how I can do this better, and well, have a great one. See you in the next video.